current revolution of agriculture aimed for precision farming. Integration of Industry 4.0 comes with intelligent and industrial agriculture. Industrial agriculture ecosystem where their farm can be managed in real time. Smart farming will apply scientific techniques in agriculture to increase crop production and the efficiency of farming processes. Fertilization control with automated system. Wireless sensor network, WSN, for monitoring system through smartphone. Here are the problem statements. The method of manual supply of fertilizer may be inefficient as the volume of spreading the fertilizer can oversupply or undersupply. The fertigation process without specifically studying the cultivating field can affect the high salinity of soil and the plant growth. Traditional farming is associated with more labor where a lot of human work are needed. The objectives are to develop fertilizer application monitoring system. To control the process of supplying fertilizer with automated system. To analyze fertilizer collected data. Here are the circuit connection to develop this system with some components that needs for this project such as Arduino UNO, ESP32, pH sensor, EC sensor, DS18B20 and water pump. The Blynk application has been used to connect the digital farming system with a smartphone for the purpose of monitoring and controlling system. The interface layout can collect the real-time data of the hydroponic system and 2 buttons for controlling pump. 3 experiments were conducted using fertilizer with different pH value and salt concentration to test the capabilities of this digital farming system to be working. The working of the system based on the optimal value of pH soil and EC of hydroponic solution for spinach cultivation. Optimal range of soil pH value between 6.0 to 7.0 pH and optimal range of hydroponic solution EC value between 1.8 to 2.3 millisiemens per centimeter. Let's enjoy the demonstration video of the digital farming system. Every experiment will be started using water as hydroponic solution. The digital farming system will supply either fertilizer or water. Optimal range of soil pH value between 6.0 to 7.0 pH. The lowest pH value of fertilizer supplied will make the soil become more acidic faster than the higher pH value of fertilizer used. However, soil pH values still in the optimal range where it is very important to make the soil in the best condition as it can provide nutrient availability for the plant to grow. When there is above or below the optimal range, it can lead to nutrient deficiencies in the soil. Optimal range of hydroponic EC value between 1.8 to 2.3 millisiemens per centimeter. The EC values in the hydroponic solution will measure the salt concentration in unit millisiemens per centimeter using the electric conductivity, EC, sensor. When the EC value in the solution is out of range value, the system will make the pump to supply the fertilizer or water for maintaining the EC value in the optimal range. The highest EC value of fertilizer make the hydroponic solution become high salinity faster than the lower EC value of fertilizer used. The optimal range also can be achieved in a short time. Every experiment is to test the fertilizer and water pump to be working. In experiment of fertilizer A and B, the water pump not worked because of the salinity level of the fertilizer used is not too high. In experiment of fertilizer C, the water pump worked to maintain the EC value of hydroponic solution in optimal range as the fertilizer used has the highest salinity level. This shows that this digital farming system can control the supply system to the hydroponic by achieving and maintaining the optimal range value. As a conclusion, the digital farming system is for controlling the fertilizer supply and monitoring the hydroponic system. This system will consider the amount of salt concentration in fertilizer to be supplied to the hydroponic solution, and the acidic level of soil in the hydroponic system. It can ease the user and farmer by reducing the workload and increasing the efficiency of farming process, and they also can get a real-time information of their crop from a distant